If one zero of the polynomial 5x square plus 13x minus p is a reciprocal of the other, find the value of p. Okay. Now, you know that a quadratic polynomial is given to you and the zeros are given to you in such a way that they have mentioned a condition. One zero is the reciprocal of the other. So now first let us write down what is given to us in the question. Now let the roots of the polynomial or the zeros of the polynomials be alpha and beta. They have given as the roots are the reciprocal of the other, means I am taking beta as 1 by alpha. You can also take alpha as 1 by beta, in which case our roots will be beta and 1 by beta. So here you have alpha and 1 by alpha. Now what is the polynomial? 5x square plus 13x minus p. Okay. Here you can see I have written down whatever I have gotten from the question, which is roots is alpha and 1 by alpha, and this is a given polynomial. That is all that I have gotten from the question. Now what is the knowledge that I already have, which I can apply over here? The sum of the roots is minus b by a and the product of the roots is c by a. Now I am going to write down the values of minus b by a and c by a. You know that the sum of the roots minus b by a will become minus 13 by 5. The roots are alpha and 1 plus alpha. So alpha plus 1 plus alpha is minus 13 by 5. Now you know that I don't need to find out alpha and 1 by alpha or their sum. I just need to find out p. Now I am going to check what the product of the roots is. It is c by a. C is minus p by 5 is equal to alpha into 1 by alpha. Because they are reciprocals, I will get a 1. So I can easily write p is equal to minus 5. This particular method is the easiest way to do this particular sum. Now it is not always necessary that every single student should think along these lines. Now I am going to write the second method, which is not very easy, but still it works in order to give the same value of p. The second method is based on the concept that if alpha is a root of fx, f of alpha has to be equal to 0. That is why we are calling it as a root. So in this case, for this particular polynomial, alpha is a root. So if alpha is a root, 5 alpha square plus 13 alpha minus p is equal to 0, and 1 by alpha is a root, means 5 by alpha square plus 13 by alpha minus p is equal to 0. I am substituting alpha and 1 by alpha in the place of x. Okay. Now you have got two equations in alpha and in p, which you should solve in order to get the value of p. Now as I told you, the method 1 is the easiest method and this is a slightly longer method because it involves a little bit of calculations. Now because the exams are near and you do not want to waste your time, you can definitely follow the first method. But if you are really interested in knowing how to find the value of p using this particular method, because when you do this particular method, you are open to a different way of thinking and there are certain concepts that you will particularly understand when you follow this particular method. It will really help you in understanding polynomials really well. But if you are interested, I want you to try it out on your own. How do you solve this equation? Take the LCM of the second equation, then rewrite it. You will get two equations. One is this and one is the equation after taking the LCM. Solve for p. You will get the same value of p as p is equal to minus 5. Okay. I want you to try and let me know if you are facing any problem in figuring this out. If alpha and beta are the zeros of the polynomial 3x square minus 5x minus 2, find alpha square plus beta square and alpha cube plus beta cube. Now this kind of sums are just mere manipulation of the formulas. So now what is given to us? The polynomial and the roots are mentioned to us. What do we know? We know the sum of the roots alpha plus beta is minus b by a and alpha beta is equal to c by a. Now let us see how we can find the value of alpha square plus beta square. You know that alpha square plus beta square is of the form a square plus b square, which can be written as a plus b the whole square minus 2ab. Correct. Now alpha plus beta, the value you already know, and minus 2 into alpha beta. Sorry. Okay. Now let us see what we are getting. You will get 25 by 9 plus 4 by 3. Take the LCM and find out the final value. In order to find alpha cube plus beta cube, I have used the formula of a cube plus b cube, which is equal to a plus b into a square minus ab plus b square. So alpha cube plus beta cube is alpha plus beta into alpha square minus alpha beta plus beta square. Okay. Now I am grouping alpha square and beta square because I already found this value when I was doing part 1. I know that value is 37 by 9. I know the value of alpha beta as minus 2 by 3. I know what is alpha plus beta. Now it is basic number crunching and you will finally get the answer as 215 by 27. If alpha and beta are the roots of 3x square minus 5x minus 2, find the polynomial whose roots are 1 by alpha and 1 by beta. Again, I wanted to figure out at least 2 ways in which you can do this and tell me what you understand by following those 2 methods. One method I will tell you is to apply the logic of sum and the product of roots. The second one is to actually find out the roots of 3x square minus 5x minus 2 and then find the reciprocal and form the new polynomial. I will do both the methods right now and I will show you what exactly is the problem with the second method. This is our given polynomial. Alpha and beta are mentioned to be the roots, means sum of the roots alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. So far we have deduced from the question. Now what do we know? In order to form a polynomial with any given sum of roots and the product of roots, the formula is this: k into x square minus sum of the roots into x plus product of the roots. We need to find out the polynomial whose roots are 1 by alpha plus 1 by beta, which means that the sum of the reciprocal roots 1 by alpha plus 1 by beta, we need to find the value. So after taking the LCM, we get, okay, what is the value of alpha plus beta? 5 by 3. What is the value of alpha beta? Minus 2 by 3. So this will give me minus 5 by 2. Agreed. Now I need to find the product of the root. So product of the reciprocal root is 1 by alpha into 1 by beta, which is 1 by alpha into beta. What is alpha into beta? Minus 2 by 3. So 1 by alpha into beta becomes minus 3 by 2. Now in order to form the polynomial whose sum is given by minus 5 by 2 and the product is a minus 3 by 2, I need to write it in this form. So the general form of the polynomial becomes k into x square minus sum into x plus product. This is my f of x. This is a general form. Now k into x square plus 5 by 2x minus 3 by 2. Okay. Now in order to form the particular value, which means that by eliminating the denominator, we have already done quite a few sums based on this particular concept when I was taking the class. You know why this k is there. You know you can substitute any value for k and you can modify this equation by eliminating the denominator. Okay, I explained all that with the reasons in that video. If you are having any doubts, please go back and watch the chapter on polynomials. Now if I modify it and write, what do I get finally? I will get the polynomial as 2x square plus 5x minus 3. This is our required polynomial whose roots are the reciprocals of 1 by alpha and 1 by beta. This is my first method and this should be the method that you should normally follow. There is a reason normally when we are doing any sums, I do not insist on any particular method. Do whatever you feel like your logic takes you, as long as it is conceptually and formula wise correct. In this particular case, I always tell my students, try to follow this particular method when they insist on the second method. I will tell you what exactly is the problem with the second method. Now in the second method, the information is the same, the polynomial and the roots are given to be alpha and beta. My students personally felt it was easier to find out the values of alpha and beta, take the reciprocal and then form the polynomial. Now what is the problem with this particular method? When I did the sum in the class, the polynomial that I gave was this. Okay, and I said alpha and beta are the roots, so they were quick to find out the roots as 2 and minus 3. Now it became very easy to find out the reciprocal, which is minus 1 by 2 and minus 1 by 3. Then they found out their sum and the product and applied. Now easy to deal with numericals rather than with 1 by alpha, 1 by beta and all that, right? Now what is the problem with this particular method? When I gave the polynomial as x square plus 5x plus 6, easily the roots came out as minus 2 and minus 3, alpha and beta. But look at this particular polynomial. 3x square minus 5x minus 2. Try to find out the roots, alpha and beta. You cannot do it by simple factorization. You have to use formulas for doing this. In every single case, it is not possible to figure out the roots so easily. Now, when you start figuring out the roots and then see that this is not working out and then you have to resort to another method, it takes up a lot of time. That is the reason I tell my students, in the first glance, if you feel that you cannot figure out the roots of the equation, always follow the sum and the product method which I explained in method 1. This method, the second method, is actually very easy if you can figure out the roots like this very easily. Then this method works. But if not, if you feel that the polynomial is a little complicated and you might take a little time in figuring out the roots, please move on to the method 1 as fast as possible so you can save time during the exam. In order to understand the difference between these two methods, I want you to try out both the methods with a few polynomials. If the sum of the zeros of the polynomial py square plus 2y minus 3p is equal to twice their product, find the value of p. A very direct question. The polynomial is given to you. It has an unknown variable p in it. We need to find the value of p. Now it is given that the sum of zeros is equal to twice their product. Now let the roots be alpha and beta. Alpha plus beta is minus b by a. That's the formula. So using that I have written 2 by p minus 2 by p, and alpha beta is equal to minus 3 because minus 3p by p will give you minus 3. It is given that the sum of the zeros is equal to twice their product. So minus 2 by p is equal to 2 into minus 3. So you will get minus 2 by p is equal to minus 6. Thus p is equal to 1 by 3. A very easy question. It can come for maybe 1 mark. So I hope you people are clear with how to approach this particular sum. If x cube plus x square minus ax plus b is divisible by x square minus x, find the values of a and b. So a cubic polynomial is given to us which is said to be divisible by this particular term, which is a quadratic polynomial, and cubic polynomial has got two unknowns a and b. We need to find the values of a and b. Now let us consider a polynomial which is not related to the question at all. X cube minus 2x square minus x plus 2, and I am telling you it is divisible by x plus 2. What do you mean by that? It means that when I am dividing this polynomial by x plus 2, I am getting a remainder of 0, that is called divisible. Or if I am substituting the value of x is equal to minus 2 in this particular polynomial, I should be getting a 0. That is what we mean by this is divisible by x plus 2. Correct. Suppose I am telling you this particular polynomial is divisible by x square minus 1. What does it mean? It means that whatever be the value of x I am getting from this by equating it to 0, that value of x when I am substituting in this particular polynomial, I should be getting a 0. X square minus 1 equal to 0 will give me x plus 1 into x minus 1. Or I can say that if this polynomial is divisible by x square minus 1, it has to be divisible by both x plus 1 and x minus 1. Because when these are multiplied together, I am getting x square minus 1. Basically, I am splitting the divisor x square minus 1 into its linear factors. Okay. So when I am substituting the value of x is equal to minus 1 or x is equal to plus 1 over here, I should be getting a 0. That is what we basically mean when we say that a cubic polynomial is divisible by a quadratic polynomial, or a biquadratic is divisible by a quadratic polynomial. We split the divisor into linear factors in order to find the number that I can substitute over here. Okay. Now let us get back to the question that is given over here, which is x cube plus x square minus ax plus b is divisible by x square minus x. Which means that I need to split x square minus x into its linear factors, which is x into x minus 1. Correct. Now, when I am equating this to 0, I am getting x is equal to 0 and x is equal to 1. So, when I am substituting 0 and 1 in this particular polynomial, my remainder has to be a 0. Clear? Now let us substitute x is equal to 0 and x is equal to 1 in this particular polynomial. When I am substituting x is equal to 0, I am getting this equation which will give me b is equal to 0. When I am putting x is equal to 1 over here, I am getting 1 plus 1, 2, minus a plus b is equal to 0, 2, b is already 0, this. Or I can say the value of a is 2. So I am getting the value of a as 2 and b as a 0. Clear? Find the condition that the zeros of the polynomial p of t is equal to t cube minus 80 square plus bt are p minus q, p and p plus q. So a polynomial in terms of t is given to us. This one, we need to find the condition so that the zeros are of this particular form. Okay. Now, when we say a condition, we need to find a relationship between the variables that are given in the equation, which is a as well as b. See, the terms p and q should not come into the condition. Whatever is given as the equation, we need to take the variables from the equation, identify them and find a relation between them. Okay. Now, let us see how we can go about it. We have 3 zeros because it is a cubic polynomial. Let us identify those zeros as alpha, beta and gamma. So my alpha is equal to p minus q, beta is equal to p and gamma is equal to p plus q. Now you know the sum and product of the zeros of a cubic polynomial. So I can write alpha plus beta plus gamma is equal to minus b by a. In this case, minus b is equal to a by a becomes a 1. So alpha plus beta plus gamma is equal to a. Now what is my alpha? P minus q plus beta is a q plus gamma is a p plus q is equal to a. I can say 3p is equal to a. Okay. Or I can say that p is equal to a by 3. So either 3p is equal to a, from that I am taking p is equal to a by 3. Fine. Now let us look at the value of the roots. Alpha is p minus q, beta is equal to p. So what is the value of p over here? Now my beta value became p, which is a by 3, which I got from here. Now what is the basic idea of the zero of a polynomial? When I am substituting that particular value in the polynomial, I should get a 0. Correct? So if I am substituting beta is equal to p, which is equal to a by 3, I should be getting a 0. Now let us substitute that value in this polynomial and see what is the relationship that I can get between the variables of the polynomial, which is a and b. Here you can see how I have substituted the value of p is equal to a by 3 in the given polynomial. So when I am substituting it over here, this is what I am getting. So a cube by 9 and a cube by 9 will get cancelled, leaving me with ab by 3 is equal to 0. So when I am cross multiplying, I will get ab is equal to 0. So the condition is that a into b is equal to 0. If y plus p is a factor of the polynomial y square plus ay plus b and y square plus my plus n, show that p is equal to so and so. So now we have a factor y plus p, which is a factor of two polynomials, this as well as this. We need to use that particular information in order to prove this. Now when you know that x plus a is a factor, when you substitute x is equal to minus a. Suppose x plus a is a factor. If you substitute x is equal to minus a in the given polynomial, we should get a 0. Or if x minus a is a factor, we substitute x is equal to plus a in the given polynomial. That is basic. So since y plus p is a factor, we have to substitute y is equal to minus p in the given two polynomials. Both the polynomials are given in terms of y. Okay. So now let us see what we are getting when we are substituting minus p in these two polynomials. After substituting y is equal to minus p, I am getting these two equations. Now equation 1 and equation 2 both has got p square. I want to eliminate whatever is common. It is always better to eliminate them. So I want to eliminate p square means I need to subtract 1 minus 2. So p square minus p square becomes a 0. Minus ap minus mp will give me this, and b minus n is equal to 0. Rearranging the terms, I will get p is equal to n minus b by m minus a. That is what is required. Find the values of k such that the polynomial kx square minus 5x plus 3 can be factorized into coincident linear factors. Now before we start doing this sum, we need to know what coincident linear factors are. Okay. Linear factors, you know, factors whose degree is 1 are linear factors like x, x minus 3, x minus 2, x plus 1. All these are linear factors. What are coincident linear factors? The linear factors which are the same, they are coincident on each other. They are called as coincident linear factors. For example, x minus 3 and x minus 3. Same factors, x plus 1 and x plus 1. When these are multiplied together, we get a polynomial, right? So they are asking if this polynomial has to be that form, find the coincident linear factors or find the value of k so that this can be factorized into this form. Fine. I hope you are clear with the question. Basically, find the equal factors. Okay, now let us see how we can go about it. Because it is a quadratic equation, I know I will have two linear factors. I am writing the linear factors, and because they are coincident, x plus a and x plus a. So this particular polynomial can be factorized into these two coincident linear factors. Okay, so this is equal to x square plus 2ax plus a square. You know, whenever we are trying to factorize a polynomial, we use the sum product method. So the sum of the terms and product of the terms, and then we try to find out the numbers in order to do basic factorization. So in this case, what is the sum? It is a minus 5. What is the product? It is a product of these two terms, c and a. So you get a 3k. What about this one? The sum is a 2a and the product is a square. So a square into 1, which is an a square. Now, since these two polynomials are equal, the sum and the product also has to be equal. Correct? Now here the sum is 2a, means I can equate 2a is equal to minus 5 or a is equal to minus 5 by 2. Now product is a square here and 3k here. So I will get a is equal to root of 3k. Let me consider the positive and the negative charges. Now since both the values represent a, I can equate both of them. So I will get minus 5 by 2 is equal to root 3k with the plus or minus sign. I am going to square it because then it will obviously become positive. So here I will get 25 by 4 is equal to 3k. Or I can say that k is equal to 25 by 12. We have found out the value of k. I hope you are really clear with this. What I did was that because I needed to find the linear coincident factors, I wrote it as x plus a and x plus a. When I open the bracket, I get this. This polynomial and this polynomial are equated to each other. Now, whenever you have a polynomial, in order to factorize it, we use the sum product method. So, I separately took the condition, which is the sum of the terms is minus 5 and the product of the terms is a 3k. Here I am getting the sum of the terms is a 2a and the product is an a square. Correct. Now, sum minus 5 and the sum 2a I equated. Product 3k and the product a square I have equated. Now, both are giving me the values of a. Equating both of them, I got the value of k. Fine. So, I will get k is equal to 25 by 12. If the zeros of x square minus lx plus m differ by 1, show that l square minus 4m minus 1 is equal to 0. So, we are given two roots which differ by 1. So, we will take the roots as alpha and beta as we normally take. So, what is given? The condition given is alpha minus beta is equal to 1. Okay. Now, let us try to find out the sum and the product of the roots of this particular polynomial and the relationship with the zeros. I am taking the roots as alpha and beta as I told you. You know the difference between the roots is given to be 1. So, alpha minus beta is 1. So, what is beta from this? Beta is equal to alpha minus 1. So, now my roots from alpha and beta, it has become alpha and alpha minus 1. You know the formula for the sum of the roots and product of the roots. See whether we can apply it over here. Sum of the roots is alpha plus alpha minus 1 is equal to minus b by a is our formula. So, here it becomes minus of minus L by 1, which is a L, or you can say 2 alpha minus 1 is equal to L. Okay. So, if I have to write alpha in terms of L, why am I writing alpha in terms of L? Because L is a variable which is given in the question. Alpha is something that I have taken. So, I need to substitute alpha with something that is given in the question. So, my alpha becomes L plus 1 the whole divided by 2. Great. Now, this is what we are getting from the sum of the rods. Now, what is the product of the rods? Alpha into beta. Alpha into beta became alpha into alpha minus 1. Correct. Now, alpha square minus alpha is equal to, now the product of the roots is given by C by A. What is the formula for C by A? M by 1, which is M. Okay. Now, I am going to substitute the value of alpha, which is L plus 1 by 2 in this particular equation and see whether I am getting this. Okay. You also try it out and see after basic manipulations whether you are able to get this as the answer. I am substituting the value of alpha over here as L plus 1 by 2. So, I will get L plus 1 by 2 the whole square minus L plus 1 by 2 is equal to M. So, here after opening the bracket, I am getting this. I am taking the LCM of 4 across and multiplying. So, this is what I am getting. After rearranging, I will get what I was asked to prove, which is this. Okay. We have done a few higher order thinking skill sums on polynomials today. You can see that those sums were slightly different from what we did before, though they were basic manipulations of the formula and the substitution of the rods. So, unless you practice more sums, you will never get to know how to do if a slightly tougher sum comes your way. And if you are having any doubts in the content or any of the question or any of the explanation that I did today here, you can drop a comment or mail me in the mail ID given below in the description box.